Hello, good day and welcome back to OTIC Geosystems. My name is Edwin, and on this video we'll be comparing the accuracy you get when you pick or when you do a survey using the Mercury GNSS receiver. So we've already, like we said in our introductory video, the Mercury GNSS receiver is an handheld GNSS receiver that has a laser and a camera that you can use to measure points even without making use of your data logger. So for this video, we are just going to set up our project, set up our coordinate system, connect to our base station, and then we'll just make use of just the GNSS receivers to pick our point, and then we'll compare the accuracies with our existing control values. So make sure you follow us on all our social media platforms, on Instagram, on Facebook, and even on LinkedIn. And then follow our YouTube channel at OTIC Geosystems. You can like, share, comment your suggestions about this video, and most importantly, click on the subscribe button. Thank you very much, and let's proceed to the exercise. Okay, so for the exercise we are doing, I'm going to set up my work mode, set up my coordinate system, set up my create my project using my data logger, and after that we'll just make use of just the GNSS to do our survey. So I'm going to connect to my GNSS now. So I'll go to go to connection, click on connection. I'm connecting using Wi-Fi, and then I'm connecting to Mercury. So I'll select the Wi-Fi name for our Mercury receiver. Now it's connected. I'll go back to Survey Master. As you can see, it is connected and it is fixed. So the next thing I'm going to do is to go to project, click on project and click on new. I'm going to save this as a Mercury test, and then from here I'll select my coordinate system. So I'm using the Lagos Vector 4 coordinate system. Select it and click on OK. These are the parameters for the coordinate system. They are all correct, so I'll click on OK and proceed. OK to create my project. So now we've created our project, we've selected our coordinate system. The next thing we have to do, already you can see that it is fixed, but if by adventure you've not connected to your base before, you just need to go to device, go to rover, and then select the work mode that you use to connect to your base. So I'll click on new, click on PDA course. I'll change PDA course to internal GSM. I'll change my protocol to course, and then the details for my course station is there already, so I'll just generate the source list to get my base station. Select my course station and then confirm, and then save this as internal GSM mode. So to apply, I'll just click on this and click on start. So connected to our base station, as you can see, it is still fixed, so we can carry on with our survey now. So okay, so at this point we can now start making use of our GNSS to pick our points, but first we need to turn on the laser with our data logger. So we'll go to topo survey page on the survey page, and from here we can click on the laser. If you see, the laser on our GNSS is now on. Also, I want to turn on the camera view, so I will click on the camera icon here so that we can see where the laser is pointing to. Now at this point, I'm not using my data logger anymore. I'll keep it aside. Okay, so our data logger is somewhere still connected, but we are going to just make use of the GNSS to pick our point. So for the first point we are going to survey, is the point. So I'm going to point. Okay, that's for the first point. This is the second point. And then for the third point. Okay, so now we finished surveying our points. So I'm going to turn off my camera now and also turn off the laser, and then I already have my coordinates, the control coordinates with me. So I'm going to elements to compare the accuracies from what we surveyed on site with what we have as the original coordinate. So for point 1, which is a OTS 0, we have a OTS A. We have our distance as 558.480.715. On the GNSS we have 558.480.718. That's 3 millimeters error. And then on the nothings we have 711.884.339 on our GNSS. On our control we have 368. So that's still around 3 cm. 3 cm is not bad. Okay, so on the height we surveyed 2.818, whereas on the control we have 2.854. That should be around 3.5 cm. That's also not bad for laser. On the second point, which is our point 2, we have on the distance we have 558.480.457. On our control we have 0.465, 457.465. That's about 12 cm. 12 cm. On the 12 mm. 12 mm. That's 1.2 cm. On the nothings we have 711.886.774 on our GNSS, and the original point is 711.886.777. That's 3 mm. On the height we have 2.841 from our survey. On the control we have 2.862. That's about 4 cm, 2 cm error. And then for the last point we have on the distance we have 558.481.090. On our control we have 0.092. That's 2 millimeters error. On the nothings we have 711.889.293. On our control we have 0.290. That's 2 millimeters. On the height we have 2.887 on our GNSS, whereas on the control we have 2.950. That's a bit far, but you know, is a laser point, so that's also acceptable for height difference. So I believe with this you can see that the accuracy for when you are using a laser in the Mercury GNSS receiver is as good as when you are using your pole to survey. So thank you very much for staying with us. We hope to see you on our next video. Do have a wonderful day. Bye bye.